In this video, we will be working a couple of problems that deal with the mean value theorem. The mean value theorem states that if f is continuous on the closed interval from a to b and differentiable on the open interval from a to b, then there exists a number c in the open interval from a to b such that the derivative of the function evaluated at c is equal to f of b minus f of a, all divided by b minus a. Now you'll recognize this as a slope equation. This is the y value at x equal b and the y value at x equal a. So we have y minus y over x minus x. So this is our slope equation. And recall that the derivative of a function is the slope of the tangent line of that function, and this one's evaluated at some point c. So we're told then that if we have a function and we're talking about an interval from a to b, the point on the graph right here is f of a, and the point on the graph right here is f of b. So this side of the equation is basically just talking about the slope of this secant line that connects these 2 points. And then the theorem guarantees that there's going to be a number c in this interval where the slope of the tangent line is the same. So basically the tangent line and the secant line will be parallel. So we can kind of eyeball that right here and see that if this is our tangent line, it's going to have a slope equal to the slope of this secant line. So that's what this mean value theorem says. It guarantees that there'll be a point C here in the interval. It also implies that the instantaneous rate of change is equal to the average rate of change. And let's do a problem. Given f of x equals x squared in the interval from 1 to 4, we want to find all values of c such that the derivative evaluated at c is equal to f of b minus f of a over b minus a. So this is our a and this is our b. So let's write what we have here. F prime of c needs to be equal to f of 4 minus f of 1 over 4 minus 1. Our derivative of f will be 2x, and so we want to put c into that derivative, so we'll have f prime is equal to 2x, so f prime of c is going to be 2c. 4 minus 1. to evaluate f of 4, we're just going to put 4 into our function. So we have 4 squared, subtract, and then f of 1 is going to be 1 squared. So our problem just comes down to solving this equation for c. And this simplifies to 2c is equal to 16 minus 1, so 15, divided by 4 minus 1 is 3. So 2c is equal to 5, which means that c is going to be 5/2. Let's do another problem then. Given f of x is equal to 5 minus 4 over x, again, find all values of c in the interval from 1 to 4 so that this is true. So this will be my a value and this will be my b value. I'm going to rewrite my function with a negative exponent here. So 5 minus 4x to the negative 1. My derivative then is 0. And then the power rule, negative 1 times negative 4 is a positive 4. X to the, subtract 1 from this exponent, so negative 2. So on the left side of my mean value theorem, I'm going to have my derivative with c substituted in for x. So I have 4 over c squared. And then on the right side, my b was 4, my a is 1. F of b, I need to put 4 into my function, so that's 5 minus 4 over 4. And then subtract from that f of 1, since a is 1. So 5 minus 4 over 1. So this equation simplifies, let's see, 4c squared equals, I have a 3 in the denominator. So 5 minus 1 is 4, minus 1, which is 3 also. So we have 4 over c squared is equal to 1. Multiply both sides by c squared. This gives me 4 is equal to c squared. So square root both sides. C is equal to plus or minus 2. Now recall that we're working in the closed interval from 1 to 4. So only the positive 2 is going to be in that interval. So our answer that we're going to give is just the positive 2.